the goodness is always in the 3 dots. And you go to change background. And look, I can be in the ocean too. Maybe. It says blooming pool of water. Is it going? What do I have to do? It's not going. Oh, there it is. Oh, it was there. There we go. Okay. Now we're all in the same place. So, okay, we're in the same pool of water. We could go on a field trip. We could go to Hawaii together. Look, we could all go to Hawaii. We just have to change our background. It's a virtual field trip. Look, we could go to Hawaii. That was the quickest flight to Hawaii I've ever been on. All right. Okay, let's go. Get going. All right. So let's do this. So right now we have talked about, we've done this before. We're doing the new separation of variables. This is the general and particular solution. Okay, you don't have that option. So Gabby, what you need to do, if you don't have your little option in the 3 dots, when we're done with class, completely shut off your Chromebook and do a full restart. You have to there's an update that's been pushed. Okay, not now, Zeta, not now. Okay. All right, but it should come up. It took my kids had to do a complete restart, and then they've got their virtual backgrounds. It doesn't let us put in our own, or we know we would all have that Disneyland castle behind us right now, right? Okay. All right, let's get going. All right, so now you can see now you could just see the virtual background instead of my ceiling. So that's nice. Okay, Dodger Stadium would be good too. Okay, though I would prefer Padres, but you know. All right. Okay, here we go. Let's keep going on separating the variables. So up until now, I've only been able to solve 2 types of differential equations analytically. So we have, in this section, so these are the types we've been able to solve, right? In this section, we will now do a more general type of differential equation. The strategy we will use is rewriting the equation so that each variable occurs on only one side of the equation. This strategy is called separation of variables, okay? So hopefully you remember this from last year. I'm going to start by rewriting, y prime as dy dx. And then we've got 2x over y. Okay. Oh, I'm not on the right one there. All right, so now I need to get all my y's go to the left and everything else goes to the right. Making sure I'm in the right. Something. I gotta make sure I have my cheat sheet out so I do this right. I know how to do it, but oh, that's not the right one. Did I do it here? There it is. Okay, got it. All right, so we're going to multiply by y and we're going to multiply by dx. All right, I am going to integrate both sides, so I'm integrating. Okay. And then we're going to add 1. So just go ahead and add 1 to the exponent, divide by the new exponent, right? And then same thing here, 2x to the second divided by 2. And then what do I need to put at the end, everybody? Tell me in the chat, what do I put at the end? All right, good job, plus c. These guys are going to cancel. It kind of depends on where the multiple choice goes from here, okay? If it is multiple choice. We know that this is a big free response question. So free response, you might kind of, other than you need to not cross out the 2's or you have to clean that part up, you might be done. But typically they do like to see it go to y equals. So I'm going to try to get it all the way to y equals. So y squared equals, I'm going to multiply everything by 2, which means I have to multiply the x squared by 2, and technically the c by 2, but this just still becomes c. Remember last year we do like c sub 1, c sub 2. You can, you don't have to. And then I'm going to undo the square by taking the square root of both sides. So the square root goes over the c, and technically there's a plus and minus out in front. Okay. All right, we doing good so far, hopefully. Okay, let's keep going. So the next box is just more of a how did we separate these things? So this is the original differential equation. It looks like I needed to subtract the x squared over and then multiply by dx to get that one separated. This one here, oh, look at this one. So this one says we've got sine of x dy dx equals cosine of x. I'm going to divide by the sine, right? So I'm dividing by the sine. What's cosine divided by sine? It's cotangent. Good. Okay. And then we'd move the dx over. So that's how they got that one. The other one here, it looks like all that we ended up doing was we took the x to the other side by dividing it, right? And then obviously the y prime came dy dx. Okay, so there you do have to make sure that you're just pulling those things apart. X is, or y is on the left, x is on the right. Okay. All right. Example 2. We are going to solve that differential there. I am going to take the dx and move it to the right by multiplying. And I'm going to take the cosine of y and move it to the left by multiplying. I should have given myself more space. Hopefully you wrote yours more to the left of the paper than I wrote mine. Okay, I have to integrate both sides now. I lost my dy. All right, so when I integrate cosine, tell me in the chat, what do we get? We do get sine. I like the fact that we used y. Good job. So sine of y equals, and when I integrate 4x cubed, I get 4x to the 4th over 4 plus c. All right, so what I'm gonna spend a line cleaning it up, and then I'm putting some space in here on purpose. All right, let's see who remembers how to get y by itself. This one's weird. So how do I get rid of the sign and I get y by itself? Who remembers? What should I do? Oh, David, good job. We got to do a sine inverse here, right? Or an arc sine. Okay, one of the two. Okay. We are doing sine inverse or arc sine. So it doesn't matter. I'm going to go with sine inverse because that's what David said first. But it doesn't matter, whichever one you prefer. Okay, so these guys cancel. You've got y equals sine inverse of x to the 4th plus 1. My sine inverse, that one is just a little gigantic, isn't it? All right, just like that. Okay? And like I said, you can do arc sine if you wanted. All right, so these two were examples of finding the general solution. So this is like we have our slope field and you've got all the different little slope fields on there, and this is like this is in general, what does that equation look like? And then the C kind of moves the equation up and down the graph. We're going to go into where this is more likely what you're going to see, and this is typically a free response question. It's usually out of the 9 points, it's usually 5 to 7 of the points. Okay. I don't think we saw one on last year's test. I pretty much guarantee you're going to see one on this year's test. Okay, it's usually on the free response on both A, B, and BC. So this is big money on points. Okay, so it's good to make sure you know how to do this. I'm hoping you guys can impress me that you remember some of these special words that we're going to use here in a minute. So finding a particular solution means we are going to find C. Okay, when we do our equation. So given the differential equation, x squared plus 4 dy dx equals xy, find the particular solution determined by the initial condition at y equals 2 and x equals -3. You know you're solving for C because they gave you an initial condition and they said the words particular solution. So I'm going to start by separating my variables. That's usually the first point, okay, is separating your variables, and you don't get any of the points if you don't show the step. So I'm going to divide by the y, and I'm going to divide by this. So 1 over y dy, I'm going to multiply by the dx at the same time. X over x squared plus 4 dx. All right, next thing we do is we go ahead and we integrate that. Okay, what does the left side integrate to? Tell me in the chat. What do we get for the left side? Don't understand this. Natural log of y. The lid on my cup is not working. I better put it in the cup holder so I don't end up with water all over. Okay. And technically it's natural log absolute value of y, technically. Okay, we're going to end up dropping those though. All right, then I have, what am I going to do to integrate the right side? What do you guys think? What should I use? Got all kinds of answers on that one, okay? The very first place you go, okay, 100% of the time is U-substitution, okay? After you've determined U-substitution doesn't work, like looking at that one, I would probably go arctan, right? If arctan didn't work, then maybe I'd go to my partial fraction decomposition, okay? If it was a fraction like that. All right, so, or long division, right? You got to make sure long division doesn't work. I'd probably do long division before partial fractions. But it is, in fact, a U-substitution. So I'm going to use the x squared. Oh, that wasn't orange. And I know it's been a few weeks since we've done a U-sub. So U equals x squared plus 4. So that's my U. Du equals 2x dx. And I don't have the 2, so I'm going to add that in, but that means I have to put a 1/2 out in front. But I have the 2x dx. So I know I've got 1/2 the integral of, I'm putting the u in for the x squared plus 4. I'm putting in du in for 2x dx, no 1 on the top. And again, when we get the integral, or when we integrate that, we get the natural log, the absolute value of u plus c. I didn't put anything in there because I'm lazy, and I'm just going to plot back in the x squared plus 4 for my u. You will not in any scoring guide ever see the U-substitution. All of a sudden, it'll just be integrated, and you go, where did they get that? Well, they did a U-substitution. Okay? Okay. Now, technically, these things in here are going to all be positive, so I'm just going to change these all to parentheses. Eventually, it would get all grouped in with like the plus c part, and it would become c anyways. I'm doing that there because I'm going to use a log property and get this up as an exponent. Okay? So we've got the natural log of y equals the natural log of x squared plus 4 to the 1/2 power plus c. All right, are you ready to impress me? Spelling doesn't count. What do I do next? I took them out, David. Ooh, Lorenzo remembered. Oh, Gabby remembered. Gabby, I think, spelled it closer to right. She might be right. All right. It is exponent. Oh, did we look it up? I have no clue how to spell it. So yeah, that's probably better. No? Okay. I try to sound it out every time, and I don't know if I ever get it right. But it is, in fact, exponentiate. Very nice. I like it. Okay. Second period told me E. So I'm impressed with the exponentiate because that's what the proper terminology. So e to the natural log of y equals e to the natural log. I'm going to go ahead and turn that 1/2 power back to a square root of x squared plus 4 plus c. Okay. I know that I can cancel the e and the natural log on the left side, so I got it down to my y equals. I cannot do that on the right side. So let's have a quick refresher on the right side. Okay. So the right side, it's like this. It's this property. So when we are multiplying, we add our exponents. But if I have 2 exponents that are added, I can take it apart with multiplication. So that's what I'm going to do here. So I really have e to the natural log of the square root of x squared plus 4 e to the c. And then this thing, really, I should have been doing like a c sub 1. This whole thing here becomes your c. So it's y equals c e. Oh, and now I can cancel this guy. I don't need the e anymore. Square root of x squared plus 4. I'm waiting. All right, are we good? I'll explain the last two steps. Yeah. Okay. So let's go back. I took this guy right here. So this is the algebraic property that we're reversing. And this is one of those weird ones where we never teach you the reverse. We only go one direction in algebra 1. So when we are multiplying, we know we have to add the exponents. Okay. So that's what I've got. But if I have two exponents that are added together, that means I can reverse that algebraic property and switch it into the same base in multiplication. So that's how I got this separated. Okay. The reason I did that was because I needed to have it just the natural log. I can't have it the natural log plus c in order for this to cancel. Okay. This guy here just becomes a c because e is 2.718. So it's a number to another number. It's just going to be a number. Okay, so that's where I got the C here. Is that better, Gabby? Okay, I'm glad that we got it explained, okay? But that at our point, at this point, we see this now. We just turn it into e to the c and c, okay? Now that we know the explanation, we just get to the point where we have that memorized and we just know that that's the process, okay? All right, what have I not done yet? What do I still need to do with this thing? We got to solve for C. Good. How am I going to solve for C? We're going to use the initial condition. Good job. I'm not going to try to isolate it, okay? I have an initial condition. Eventually, yes, I guess I do isolate it, but I'm going to plug in my initial condition first. I'm not going to do algebra before I do that. So 2 equals the c square root of -3 squared plus 4. So 2 equals c. 9 plus 4 is 13, right? And then I'm going to divide by the square root of 13. So 2 square root of 13 equals c. And to get your final answer, you're going to take this guy and you're going to plug him back into the equation, right into the step right before you plugged in your initial condition. So y equals 2 square root of 13 square root of x squared plus 4. So what that really means is if I had a slope field that had all this differential, all the slopes for that differential, okay, and I went to this particular point, the point -3, 2, and I drew the curve, this would be the equation of that curve that would go through that point. All right, we're going to do one more. Oh, there's other good stuff in this one.
Miss Ballard?
Oh, 2 more to do. Cool. All right. 4 has some good stuff in it, though. So we got to remember. All right, let's try again. So initial condition 0, 1. Find the particular solution for the equation xy dx plus e to the negative x squared y squared minus 1 dy. First thing I'm going to do, and it's very rare that we do an addition subtraction with these, but I have to get this mess to the other side. The only way to do that is to subtract it over. So that's where I'm going to start. So e to the negative x squared y squared minus 1 equals negative xy dx. Okay, I am going to divide by the e to the x squared, and I'm going to divide by y. Okay, so I've got y squared minus 1 over y equals negative x e to the negative x squared dx.
Miss Ballard?
I'm going to do some algebra. I forgot the dy. Thank you, Gabby. I saw that pretty quickly, didn't I? Okay, I'm going to split this into 2 fractions. So y squared over y minus 1 over y equals negative ex. There's something I could do with that. There's something that we don't like about the look of that. What would make that better for us to integrate it? What algebra could I do first? Yeah, the negative exponent. And to get rid of that negative exponent, I've got to go ahead and bring it upstairs. So e to the x squared dx. All right, I'm going to go one more line, get this clean. This thing here is going to cancel the y into the y squared. So it'd be y minus 1 over y equals negative x e to the x squared dx. And we are definitely ready to put integrals on it. I now can finally start doing calculus because I really haven't done any. I separated the variables. That was a little bit of calculus. All right, let's go ahead and integrate. So I get the integral of y would be y squared over 2. 1 over y. I lost the dy again, didn't I? It just kept falling off. Okay. 1 over y is minus the natural log absolute value of y equals. What do you think how do I integrate this x e to the x squared? Remember the first place you go. It's the first thing I should check. Thank you. I love, how do we do partial fractions if there's no fractions? Okay, I like that we all tried to go to parts because you guys are kind of right. You saw the multiplication, you saw that chain or the product rule, right? But you always look for the U-sub first because it's going to be a lot easier, right? And if you think about it on parts, if you start the U-sub process, you're really starting the parts process too, right? Okay, so let's go for our U-sub. I'm going to use the x squared as u. So u equals x squared. That means that du equals 2x dx. Got a 2 out there, and I'm going to have to put a 1/2 out in front. But I have all the other parts. So we're good with the U-sub piece. So we've got negative 1/2. When I integrate, I'll go ahead and show the steps, sorry. E to the, I was going to integrate in my head. E to the u, and then for the 2x d, oh, that's the wrong color. 2x dx, I'm putting in du. All right, when we integrate e to the u, what do we get, people? E to the u, good job. Is that it? Just e to the u? Ah, yes, plus c. Okay. You guys are doing pretty good. You're keeping up pretty good. All right. So here's the thing. That would not be, look at this function right here. This is not something that we would try to get y by itself on. Okay. That's with the y squared mixed in there with that natural log of y on the inside. That's insanity. They would not likely have us solve for that. The one thing I should do though is I should have put my x squared back in there, right? I should have subbed my u back in. So I'm going to fix that. So at this point, I still need to solve for c. So I am now going to sub in my initial condition. Okay. So I've got what the y value was 1. So 1 squared over 2 minus natural log absolute value of 1 equals negative 1/2 e to the 0 squared plus c. Got all kinds of good stuff to review there, don't we? Yes, you can do that, Natalie. Okay. If it works, and you might have to, like on something like this, you might have to. Okay. All right. Although this one, it still wouldn't. Yeah, I still probably wouldn't simplify this one. Okay, so 1/2 squared would just be 1/2, right? All right. What's the natural log of 1? Oh, you guys are too good. I didn't even ask the question. You all are mind readers. Okay, so it's 0, so that goes away. All right, do you know what's okay? I didn't even ask it yet. You knew my next question, didn't you? All right, so -1/2. E to the 0 is 1. Thank you for everyone who put it in the chat, plus C. So it's just going to be -1/2. All right. Psychic. No, you guys are just brilliant mathematicians. You all should be math majors. Okay? I'm going to get you all shirts that say future math majors. Okay. All right. We are going to add the 1/2 to the other side. So when I add the 1/2 to the other side, I would get 1 equals C. All right, which means I'm going to the line before I plugged in my initial condition, and I'm plugging my C. Okay. All right, so we've got y squared over 2 minus the natural log absolute value of y equals -1/2 e to the x squared plus 1. All right. And then again, I probably would not take that to a y equals on this one, just because of how ugly it is. Okay. All right, we got one more. Ooh, this one has a good thing going on. The exponent's kind of crazy. So at the end, so we're gonna try this one. Which algebra step? What color is it? Is it the adding the C? Is it y squared? It's way up. So going from here to here. Okay, so remember when I have a single fraction, I'm allowed to take it apart and it has the same denominator. And then I know that y divides into y squared and I just get a single y. Is that better? Yep, okay, sorry I went too fast. All right, let's see if we can get this last one in in 8 minutes, okay? All right, so we are going to find the equation of the curve that passes through the point 1, 3. So notice your initial condition was stated 3 different ways, okay, in these problems. So that's just your initial condition, okay? Slope of this, so that's your dy dx equals y over y squared. Be sure to, I'm not worried, we're not going to state our domain. It's really funny because the answer key didn't even, from the guy I stole it from, didn't state the domain either. All right, so we're going to separate our variables. That's step 1, okay? Who's Ryan? Okay, all right. All right, we're going to put the dx on the right and the y on the left by dividing. So you've got y, the y divides, the dx multiplies. Oh boy, look at that. Oh, avid tutor. Okay. All right, and then I am going to bring this upstairs. So 1 over y dy equals x squared to the -2 dx. Oh, Ryan isn't the guy who teaches AP Readiness. It's Lundstrom. I don't know what his first name is. Maybe it is Ryan. I don't know. Lundstrom is his last name, though. Okay. You guys are all going tomorrow, right? Because I'm going to sit here. Okay. Extra credit tomorrow, and I'll put it in before the cryo grade gets cut. Okay? All right. And he's doing related rates, so tomorrow's a good one to hit up. Okay? You all need that. All right. We're going to integrate. So we get natural log absolute value of y equals, I have to add 1, so you get x to the -1 divided by -1 plus c. All right, I'm going to go ahead and drop the absolute values off of there. It's just going to be natural log of y equals. I'm going to bring this back downstairs, so -1 over x plus c. Okay, what do I do now? You could do the initial condition. Is there anything else I could do instead of the initial condition right now? There's two ways to do this. Oh, there we go. I would probably choose to exponentiate. That would be my thing, okay? You could plug the initial condition in and do it here, okay? If you, the upside of doing that is you get the point for the initial condition now versus later when you're taking the AP test. Every time I've ever done it that way, I somehow screw up the algebra and get the problem wrong. So I always exponentiate first, okay? But that's me. So I'm going to exponentiate e to the negative 1 over x plus c. These guys cancel, so y equals, and I'm going to split that up. E to the c, right? So y equals, yeah, I think his name is Ryan. All right, c e to the negative 1 over x. Now I'm going to plug in that initial condition. So my initial condition was y is 3 and x is 1. I'm going to divide by e to the negative x. So 3 divided by e to the negative 1 equals c. What do we not like about that picture right there? He does go really fast. But that's probably good for you to experience because I go really slow compared to your college professors probably. Negative exponent, that's right. So we're going to move that up. So c is 3e. Okay, so here comes the interesting part of this problem. I'm going to plug c back in to the line before I put my initial condition in. So y equals 3e to the times e to the negative 1 over x. We are multiplying, which means what do we do to these exponents that are right here? We have to add them. This is a fancy exponent of 1, so I get a common denominator that's the same. So y equals 3e to the x minus 1 over x. You might also see 3e to the 1 minus 1 over x. Okay, how are we doing? We doing all right? You ready for a joke?
Miss Ballard.
I'm not going to do a joke at all today. I forgot to do it second period.
Miss Ballard.
Yes, Gabby, what's your question? Well, you hadn't had the lesson yet. You weren't supposed to do the homework yet. All right, Gabby, what's the question?
Nice. 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 Nice.
You can exponentiate on, as long as you have, the only way to get rid of the natural log is to exponentiate. So if you have to solve for whatever's inside here, you have to exponentiate, even if it's on one side or both sides or whatever. That's the only way to get rid of it. Okay. Log would be a little bit different, and we don't use common log a whole lot. If you see a log, it's probably going to be in a derivative more so than an integral on your test. Okay. David, what's your question?
So when you isolate,
we can't hear you. I don't know why you can't hear we can see you talking, but we can't hear your microphone. Can you type it in the chat? Sorry. Sometimes that happens. Oh, you can hear him? I don't know why I can't hear him. For where I put the star. Okay. Got it. So right here. What's wrong? I can't hear him typing or anything. It's just when you isolate the y, right? Yes. Okay. Yes. So that's always after you get the C, that's always where you go back to. So I usually go up one line from where I put in my initial condition. Okay. All right, are we good? I'm going to go back to the beach. There we go. All right. I actually don't appreciate the beach. I don't enjoy sand that much. Oh, I'd rather be on a boat on a lake. All right, let's do a joke. I got to find Flipgrid though, because I don't have it going. And then we will release class. It is 12:30, so if you've got to go, you've got to go. But all right, wait, I gotta get it open. I think he had a pretty good one yesterday. He didn't do a new one today. I wasn't around. I went to go get. Oh, maybe he did do a new one. It says the 6th. All right, 0 views. Cool. Here we go. Okay, we'll see how messy the toys are today. If you don't enjoy picking up toys, don't have 4 kids. All right, here we go.
The only reason.
Oh, I can't hear him either. What's going on? Oh, I know why I can't hear David. My speakers were muted. All right.
Hey guys, two reasons I have a smile on my face. One is that I'm going to tell a really funny joke to you. Well, I think that you. Oh wait. Hi, so as I was telling you, I'm going to read you a joke and also sending a virtual field trip.
Got to go on a virtual field trip to the San Diego Zoo today.
Multiplier.
He said he was excited until he found out he had a sub all day. Then he's not as excited. He's like, Mom, it's not going well. I didn't hear the joke, though. I got to do it again.
Study for math. So what tool is best studied for math? Multipliers.
Oh,
it's couple styles and still kind of in November because I'm gonna be leaving for 2 more days. Yeah. I'm gonna be on the road.
Well, I don't know how he's going to be on the road. We're not going anywhere. Okay, maybe he's got a gig telling jokes somewhere. I don't know. I don't know how he's getting there either because he can't drive. All right, you all have a good weekend. Please get some more homework turned in, and I will see you all on Tuesday. Okay, maybe we'll go somewhere besides Hawaii. Okay? All right, have a good weekend, guys. Bye, Habib.